Hello and welcome back guys. In this video we are going to write the code for solving the sudoku board. Now going back to our board.js file, at the top we are going to import memo2d library from /lib/memo2d. This will help us keep track of which number has appeared in which row, column or sector. If we don't use something like this, we will have to check all the 9 cells for the row, 9 for the column and 9 for the sector to check if the number has appeared in any of them. So we will use this memo2d. And then we are going to import getSector from /util/utils.js. GetSector again gives the sector when the row and column is passed as parameters. Cool. Next we are going to go inside our class and we are going to initialize a few more properties. First we have prev, which is initialized to null. When going through the board, this basically stores the value of the previously edited cell in the DOM. And this is only used for visualization purpose. We are going to use this to add and remove classes from the cell's HTML element. Then we will have speed, which is basically used to store what the time difference between two steps should be. Then we have this row, column and sector, which are all initialized to null. And these are going to be used to store the memo for the row, column and sectors respectively. And finally, we have solved, which is going to be initialized to false. This, as the name suggests, will be set to true as soon as the board is solved. Cool. These are all the properties that we will require. Now, moving on to the first function, we are going to start from the entry point, which is the event handler that gets executed when the user clicks the solve button on the screen. So we are basically going to do this in reverse order. We are going to use a function, decide what its functionality is, and assume that it exists. So we are actually using a function before creating it. But since we have decided what it does, we create it after that. Then if the function requires another function, we create it after that, and so on. This is a method that I use many times while solving a problem when I haven't planned out everything beforehand. Cool. So this is going to be a simple event listener. We are going to call it setupBefore and solve. And it will be an async function since we are going to animate how the board is being solved. First, we are going to set this.solve to false. Even though we have initialized it to false, this is in case we are trying to solve a second board after solving the first one, in which case this will be required. Then we are going to use this.createMemo, which is going to initialize the row, column and sector memos. And if we have some board configuration given using the simple input or the array input, it will be added to those memos as well. So if we have set second row, second column as 3, then the row memo for second row and number 3 will be true, column memo for second column and number 3 will be true, and sector memo for first sector and number 3 will be true. Again, I'm using this form of sector structure, so second row and second column is a part of sector 1. Now this create memo is expected to return true if it was able to set up the memo successfully, but it will return false if it wasn't able to do so because some row, column or sector had a repeating number. So we can move this into an if block. So if this.createMemo, then we are going to await this.solveBoard, which is the main function which will solve the board, and then we are going to check if this.solved is true or not. If it is not true, we can alert that the board is not solvable. Now before we start solving the board, we are going to disable the solve button using event.target.setAttribute disable to true, and once it is done, we are going to set it back to false. This way an user will not be able to click the solve button multiple times. Now moving to this createMemo function, inside this function, we are going to initialize this.row to a new memo2d object, the same for column and same for the sector. Cool. Then for the next step, we are going to wrap it in a try and catch block. Inside the try block, we are going to call this.setupMemo, which if there is some existing board configuration that we gave from the user input, then it will add to the memos. And we will return true. And if it goes into the catch block, we are going to alert e.message and then return false. We are expecting this dot setup memo to throw an error if there are any repeating elements in the same row, column, or sector. Cool. Now for setup memo function. So we are going to do this dot board dot for each, where we will get this row and row index, and let us call this board row. And board row dot for each will give us the cell and the column index. Inside we are going to check if the cell dot value is empty or not. If it isn't, then we are going to do this dot row dot set val with the row index, the cell value which is the number, and we'll set the value as true. We have to do something similar for the column and the sector as well. Now, if you remember when we were creating the memo2d library, setVal returns true if it was successfully able to change the value to true. If it was already true, it will return false. So we are going to move all this into an if statement and check if any of them returned false by doing this. And in this case, we will throw a new error and the message can be incorrect board. So moving back to our setup before and solve function, we are done with the create new memo. So let's move to the solve board function. Before moving on there though, there is one minor thing that we need to add. So we are going to go to set cell value and we are going to add one more parameter. We are going to name it visualize mode and the default value will be true. Basically, this parameter will be checked in set cell value, and if it is true, we are going to do this. So if visualize mode, then we are going to check if there is a prev. If you remember, prev stores the previous cell that was edited. So if prev exists, then we are going to remove current from its class list like so. After that, we are going to add current to the current cell's class list like this. The current cell can be found with cell.$L as you remember. And finally, we are going to set this.prev equal to cell.$L. So the next time when we are calculating for the next cell, we get the proper previous cell. Now, wherever we have called this.setCellValue, we are going to find them and add false as the fourth parameter because all these don't require visualization. They are just init steps. Visualization is only required during solving. Cool. Now that is done, we are going to create the solve board function. This will be an async function as well, and it will take in row and column as parameters, which will be initialized to 0. Row and column is for the cell which we are supposed to start solving from. And we haven't used them to pass any parameters yet. We will do that soon. In this function, first we are going to get the actual first unsolved cell. So the row and column means that we are starting to solve from this point. It doesn't mean that it is actually unsolved. It could have been entered as a part of the initial board configuration. So we are going to use this get first unsolved. We are supposed to pass in row and column and we expect x and y, which are the first and second index of the first or next unsolved cell. Now let's say that there are no more cells left to solve and we have reached the last cell. So in that case, we expect x and y to be false. So we are going to add an if check here. If x is false and y is false, then we can return true, indicating that the board has been solved. Then we are going to get the sector of the first or the next unsolved cell. We are going to use get sector and we are going to pass in x and y. Cool. Then we are going to initialize solved to false. Now looping from 1 to 9, we'll check if I has appeared in the given row, column or sector. So we will check if this.row.checkIfIn and pass in x and I. Then we'll do the same for the column where we will pass y instead of x. And then we'll do the same for the sector where we will pass s. So if all of these are false, then we can try this number and try to move forward with the next cell. So we go inside this if block here and we use this.try1. And it'll be an async task, so we'll have to await for it. And we are going to pass in x, y, and s, which are the row, column, and sector values. And we'll also pass in the number as well. And we expect a boolean here. If it was able to solve it with this number, it returns true, otherwise it returns false. So we are going to update solved with it. Then we are going to check if it is solved, at which point we can set this.solve to true and break. Otherwise, we'll continue on with the loop. At the end, we return solved, so if the board is solved or not. Now, moving on to get first unsolved, this function will take in row and column and it will return the first unsolved cell. So first we are going to loop for the row. I will start from the row that is passed in the parameter and it will go till 9 and we'll increment 1 with each cycle. Then for the column, we are going to check if the current row, that is I, is equal to the starting row as passed in the parameter or not. If it is equal, we start j from the column, otherwise from 0. And we are going to use this ternary operator to do that. Because let's say that you're supposed to start from second row, second column. Now, if you move to third row, we should start from the first column in the third row because it comes after second row and second column. Hope that makes sense. So inside the second loop, we'll check if the value of the cell is empty or not. And if it is empty, we return I and j in this array. Otherwise, at the end, we return false and false. Now moving on to try1. This function will take in row, column, sector, and number, and it will return a promise. Moving inside, the first thing that we are going to do is set the data for the memos and the actual cell value. So we are going to use this.row.setval, row, num, and true. Similarly for column, this.column.setval, column, num, and true. And for sector, this.sector.setval, sector, num, and true. Now once we have set the value, we are going to create a timeout. And this is for the visualization purpose. And the gap is going to be this.speed. Cool. Now inside the set timeout callback, we are going to do this.solveBoard again, and this is for solving from the next cell. We will pass the row and column again, and we can do that because this row is filled now, and get first unsolved will skip this cell in the solveBoard function. And with this.then, we'll get the result of the solveBoard function. Since solveBoard is an async function, you can either await its result or use .then to get the result in the callback. So with .then res, we are going to check if res is true or not. If it is not true, so we were not able to solve the board with it, we're going to clear the data that we just set. So we are going to copy this from up here and paste it here and change the value from true to false and num to empty. And at the end, we are just going to resolve res. Now this neat little trick is called recursion in programming. So what is recursion exactly? Well, if you Google recursion, it will tell you the definition of recursion is this. Recursion is a method of solving a problem where the solution depends on the solutions to smaller instances of the same problem. So here we have the problem which is solving the board. We break it up into solving one cell and the remainder of the board. This goes on until only one cell is left and we are able to fill it up. If at any point we can't fill it up with any number, let's say that none of the numbers from 1 to 9 fits at one cell, it returns false to the previous call of solveBoard and it tries the next number there and tries to move ahead. This is how backtracking comes into picture. Okay, so let's visualize it in a better way. Let's say we start from solveBoard 00 and get first unsolved returns, let's say 03. Then we see that the number 5 fits here since 1 to 4 has appeared in the same row, column or sector. It then calls try1 with 0 and 3 and the sector will be 2 and the number will be 5. Try1 sets the value and moves forward, meaning that it calls another solveBoard with 03. Now since 03 is already filled, get first unsolved will return something else. Let's say that it returns the very next cell, which is 04, and we see that the number 8 fits in it. Then again, this calls try1, it sets the val and it calls another solve board. And this goes on until let's say that the next solve board sees that it can't fit any number in it. So 1 to 9, nothing fits. So what it does at this point is it returns false. It does this because we initialize this solve to false and 1 to 9 nothing fits in it, so it remains false and it returns it. It then comes back to the previous try1 where it clears the cell and returns to the previous solve board for 0 and 4. And then it tries the number 9 and it moves forward again. And again it sees that nothing fits. So it returns false again, which comes back to this solve board, and now even this is out of choices. It has solved as false and it returns it to the first try1, which returns it to the first solve board, and it tries the next number there and moves forward. This will go on until we reach the last unsolved cell and solve it. And after that, for the next pass of solve board, get first unsolved will return false false since all are solved, and that would trigger this break at every solve board loop, and we finally have a solved board. Cool. Now let's see this in action. Let's go to our index.js file and add this event listener like so. And now let's go to our browser, set some initial value and solve. Let it run for a while. And it is able to solve it. Now there is only one minor thing that is pending, and that is how to modify the speed. So let's go back to our board.js file and quickly make this event listener for it. We will call it handle speed input, and this is a simple event listener. So it gets event as a parameter, and we will destructure it right here and get value from its target. Then we set this dot speed as value and convert it to a number with this unary operator. And going back to our index.js file, we'll quickly add this event listener as well. And when we go back to the browser and check, we are able to adjust the speed. Now that is going to be it for the video, guys. I know that it was a long one, and if you were able to reach till this point, it is really great. You did a great job. This series did not only focus on learning algorithm, but also combine it with front-end development into a fun little project. Hope you were able to benefit from it. I hope to see you guys in the very next video. Don't forget to like, share, subscribe and comment. Bye.